Our today's topic is V model. V model is a very popular development process model, and this is actually the variant of the waterfall model. And here, this name of this model is V. Why the name of the model is V? Actually, the visual appearance of the model makes the name of this model. So visual appearance is matter here, and that's why the visual appearance is like a V. So the model name is V model. In this model, verification and validation activities are carried out throughout the development life cycle, and therefore the chances of bugs in the work products considerably reduce. This model is generally considered to be suitable for use in projects concerned with development of safety critical software that are required to have high reliability. So this type of projects, the projects which requires high safety and there must not be any error, this type of projects needs V model. Why this type of projects need V model? Actually, what we actually told, the third point, that is verifications and validations carried out throughout the phases. So that's why we use V model for a project which needs very much safety. This is the picture of V model. Here we can see different levels of different phases are there, like requirement analysis, and there is high level design. That means high level design means the testing part, that is integrations and system testing are there, and there is a coding part, and in coding part is actually in coding, after coding we have the unit testing part also, and here we can see the interaction between these phases. So here two main phases are there in this model, that is development and validations. So the left half of this model comprises the development phases, and right half of the model is validation phases. In each development phases, along with the development of work product, test case design and the plan for testing the work product are carried out, whereas the actual testing is carried out in the validation phase. The validation plan created during the development phases is carried out in the corresponding validation phase, which have been shown here. In the validation phase, testing is carried out in 3 steps, that is unit testing, integration testing, and system testing. The purpose of these 3 different steps of testing during the validation phase is to detect defects that arise in the corresponding phases of software development, requirement analysis and specification, design and coding respectively. So this model is very important model, and this can be used for our project secure and safety. Now we will discuss V model versus waterfall model. What we actually pointed out that V model can be considered to be an extension of the waterfall model. However, there are major differences between these two. What we already mentioned, that in contrast to the iterative waterfall model, where testing activities are confined to the testing phase only. So in the V model, testing activities are spread over the entire life cycle. And in this previous figure, we can see that during the requirement specification phase, the system test suit for design activity takes place. During the design phase, the integration test cases are designed. During coding, the unit test cases are designed. Thus, we can say that in this model, development and validation activities proceed hand in hand. Now, we will discuss the advantages of V model. There are very important advantages of V model over the iterative waterfall model. So the first advantage is what we can point it out, the testing activities. In the V model, the testing activities is done much more. That means test case design, test case planning. And these activities are carried out in parallel with the development activities. So before testing phase starts, significant part of the testing activities, including test case design and test planning, is already complete. So therefore this model usually leads to a shorter testing phase and an overall faster product development as compared to the iterative model. And secondly, the test cases are designed when the schedule pressure has not built up. So when there is no pressure, the work will be very much, the quality of work will be very much higher, and the test cases quality is obviously very much better. Now, thirdly, the test team is reasonably kept occupied throughout the development cycle, in contrast to the waterfall model, where the testers are active only during the testing phase. This leads to more efficient manpower utilization. And finally, in the V model, the test team is associated with the project from the beginning. So they build up a good understanding of the development artifacts, and this in turn helps them to carry out effective testing of the software. So in the waterfall model, often the test team comes on board late in the development cycle, since no testing activities are carried out before the start of the implementations and testing phase. But in V model, throughout the model there is a testing techniques is occurred. So this is a very much important thing about V model. Now we are discussing the disadvantage of waterfall model. So what we actually said that V model is actual extension of the waterfall model. That means this model is actually derivative from the classical waterfall model. That's why this model inherits most of the weakness of the waterfall model. Our today's topic is prototyping model. Now we will discuss the prototyping model. This prototyping model is also very popular life cycle model. The prototyping model can be considered as extensions of the waterfall model. This model actually suggests to build a working prototype of the system before development of the actual software. A prototype is a toy and crude implementations of a system. It has limited functional capabilities, low reliability, and inefficient performance as compared to the actual software. A prototype can be built very quickly by using several shortcuts. The shortcuts makes the whole thing much more inefficient. When a project is done in very quickly and with taken so many shortcuts are there, so it involve actually developing inefficient, inaccurate, and dummy functions. The shortcut implementation of a function may produce the desired results by using a table lookup rather than by performing the actual computations. So this is actually the rapid prototyping. This rapid prototyping is used when software tools are used for prototype construction. For example, tools based on 4th generation languages may be used to construct the prototype for the GUI parts. Now we will discuss the necessity of the prototyping model. The prototyping model is advantageous to use for some specific types of projects. So at first, this model is very much advantageous to use for development of the graphical user interface part of an application. Through the use of prototype, it becomes very easier to illustrate the input data formats, messages, reports, and the interactive dialogues to the customer. So this is valuable mechanism for gaining better understanding of the customer's needs. So the prototype model turns out to be especially useful in developing the graphical user interface part of a system. For the users, it becomes much more easier to form an opinion regarding what would be more suitable by experimenting with a working user interface, rather than trying to imagine the working of a hypothetical user interface. So we can say that the GUI part of a software system is almost always developed using the prototyping model. And secondly, this prototyping model is especially useful when the exact technical solutions are unclear to the development team. A prototype can help them to critically examine the technical issues associated with product development. Suppose there are situations where the development team has to write a command language interpreter as part of a graphical user interface development. Suppose none of the team members has ever written a compiler before. Then this lack of familiarity with the required development technology is a technical risk. This risk can be resolved by developing a prototype compiler for a very small languages to understand the issues associated with writing a compiler for a common language. Once they feel confident in writing compiler for the small language, they can use this knowledge to develop the compiler for the command language. So for major design decisions depend on issues such as the response time of a hardware controller or the efficiency of a sorting algorithms. In such circumstances, a prototype is often the best way to resolve the technical issues. Thirdly, an important reason for developing a prototype is that it is impossible to get it right the first time. One must plan to throw away the software in order to develop a good software later. So the prototyping model can be developed when development of highly optimized and efficient software is required. So we can conclude that the prototyping model is considered to be useful for the development of not only the GUI parts of a software but also for a software project for which certain technical issues are not clear to the development team. Now we will discuss the life cycle activities of prototyping model. The prototyping model of software development has two important phases, that is prototype development phase and another is iterative development phase. So in the prototype development phase, the development starts with an initial requirements gathering phase. So in this phase, a quick design is carried out and a prototype is built. The developed prototype is submitted to the customer for evaluation. Based on the customer feedback, the requirements are refined and the prototype is suitably modified. So this cycle of obtaining customer feedback and modifying the prototype continues till the customer approves the prototype. So this prototype development phase, that means the project developer needs to develop a small prototype of the project and it submit to the customer, and customer check whether the all requirements are actually satisfied by this model or not. If the whole things are satisfied, then okay, and they provide the reviews, and according to the reviews, if the reviews is actually not that means the review can be that the model need to some modifications to make the customer requirements, then the model has to be rebuilt, and this rebuild procedure will be going on until all the customer requirements is satisfied. So according to the reviews, it will be designed again and again. So this is the prototype development phase, and after that, when this that means when the prototyping model is actually approved by the customer, the actual software is developed using the iterative waterfall approach. So here the same thing what we actually read in iterative waterfall model, that the SRS document is also very important here, and in spite of availability of working prototypes, the SRS document is actually needed to be developed, since the SRS document is invaluable for carrying out. For GUI parts, the requirements analysis and specification phase becomes redundant, since the working prototype that has been approved by the customer serves as an animated requirement specification. The code for the prototype is usually thrown away. However, the experience gathered from developing the prototype helps a great deal in developing the actual system. Here we can see the life cycle of prototyping model. So this is the graphical representations of prototyping model. Here we can see the model is divided into two parts, that is prototype development part and iterative development part. In the prototype development part, we can see the first point is requirement gathering. That means the customer's requirement has to be gathered. This is the first things what to do. Next, the software developer need to develop a quick design of the whole project. So after this quick design part, there is a build prototype. And when the prototype is built, it has to be provided to the customer, and customer evaluation is much more important here. And customer get this prototype model from the software developer, and they produce some reviews, and or you can say that the suggestions, and according to the reviews that model has to be designed again. So when the prototype is accepted by the customer, then the phase can be changed. Then the project can be entered into iterative development phase. This is like our iterative development, iterative waterfall model. And all the phases, that means design, implementation, testing, maintenance, all the phases are there, and there is a feedback path of this. Means this is the iterative model, so feedback path is here. So this is the overall design of the prototyping model. Now we can discuss the strengths of the prototyping model. So throughout our discussions, we can now identify what can be the strength of the prototyping model. So this model is actually most appropriate for projects that suffer from technical and requirement risks, and a constructed prototype helps overcome these risks. So in this side, we can say that the prototyping model has a strength to handle the risky software, and the software which is really unknown to the project developer. Now we are discussing the weakness of the prototyping model. The prototyping model can increase the cost of development for projects that are routine development work and do not suffer from any significant risks. So why the cost is increased here? Because in this model have a part, that is the prototyping part, which is not actual development of the project. So at first a small model of the project is developed. So the project development team has to be put emphasize and has to be produced money in that regarding this prototype development. So it increases the cost, and when there is a risk in the project, the prototyping model is effective only for those projects which for which the risk can be identified before the development starts. Since before the development phase we are actually creating the prototyping model, the prototype is actually constructed only at the start of the project, and the prototyping model is ineffective for risks identified later during the development cycle. So the prototyping model would not be appropriate for projects for which the risk can only be identified after the development is underway.